If you put an image to an LLM, you can ask question from it. But how? How can an LLM see an image? To enable that, we use a technique called vision transformers. So let's see how it works. For this video, let's take this scenario. We take this image and input it into ChatGPT. First thing it does is it divides the image into different patches. As you can see, I have divided this image into 16 by 16 pixel patches. Why we process in patches and not pixels? The thing is, if we use pixels, there will be large amount of pixels, resulting in a huge computational cost. If we take one of those single patches, it's three-dimensional. What I mean is, we have width, we have height, and also RGB colors. AI can't process three-dimensional data, so what it does is it converts this three-dimensional data into a single array. We call it the flattened layer. Then we take that list and multiply it with a matrix. The thing is, this matrix is learned from the training process of the AI. And the result is something called the embedding. The embedding represents different visual features of that patch. And also, if we take two embeddings of similar patches, they tend to be a lot similar, and different patches result in different embeddings. So the same process is done for all the patches, resulting in what we call the embedding matrix. In previous steps, what we did was we converted the image into a format that's easier for the model to understand. If we think about it, there's a little problem. We took the 2D image and turned it into a one-dimensional array. So it basically removed all the information about different positions. What I mean is, model needs to know things like this patch is located in left top, and this patch is located in center, and this patch is located in the bottom right. So how we make the model know about the positions of each patch? To represent locations, what we do is we take our initial embedding matrix and add it with a new matrix called positional embedding matrix. This positional embedding matrix is another trained matrix that's learned during the training process of the model. During the learning process, the model figured out an efficient way to represent positions having different values at positional embedding matrix. This is the matrix we get after adding positional embeddings. Now, all the pre-processings are done. Next, what we do is we send the matrix into the transformer. Then the transform performs attention to each patch and produce the output. And as you can see, the output is something like that. It mentions the fact that the image is a city street and there are cars, people, and buildings inside the image. So that's basically it. This is how it works. We first take the image, turn it into different patches, we flatten those patches, and then we turn it into embeddings. After that, we add it with the learned positional embeddings, and finally, we send it to the transformer and get the output. But if you think about it, there's a huge problem. If the resolution of the image gets really large, let's say 4K, 8K, and even larger, because the resolution is big, there's going to be so many patches. And when there are large amount of patches, computational cost going to be really, really high. To reduce this problem, there are many solutions like shifted window adjustment. But even though there are these solutions, the core issue still remains. To completely solve these issues, what we need to do is be more innovative and change and improve the whole AI architecture.